All right, and you guys be quiet because we got a lot of things to do. So integration by parts is one of the integration techniques 100% on the BC exam. So I will tell you, for the next 3 things that we're going to talk about, some are not on BC exam, but I will tell you, but you're still going to have tests on it. Some are going to be on BC exam 100% of the time. Integration by parts is 100%. It's going to be on the BC exam, 100%. So you have to know this subject very well. But the next 2 subjects, some subject is going to be on, some subjects not going to be on. So you know like which one you need to be more emphasized. But if you want to do good on the test, you need to emphasize on everything. But from now on, this is where the game begin. Okay, which is first time we're gonna only talk about BC topic. So we're gonna deal with BC topic. Now, let's talk about something that we have learned how to integration. Now, which thing that you don't know how to take integration? We know how to take integration e to the x, sine of x, cosine of x. Which thing that I cannot take integration of? Which function I cannot take integration of? Do you know? Yep. Natural log of x, like integration natural log of x, if you realize that we know the derivative is 1 over x, but we don't know what's integration natural log of x. We know the integration of e to the x and derivative of e to the x. That's like the easiest thing in the world. And we know how to do all the trig functions, but natural log of x, think about what, what derivative is going to give me natural log of x. Can you think of me a function that derivative end up to be natural log of x? Just like if I give you nothing to start with, which function you think could shift? Shut the hell up. Thank you. Yes. You need to pay attention over there. Which function that you take a derivative is going to result into natural log of x? See if anybody can come up. I'll give you extra credit if you can come up with it. Oh, no, do not fear. You already know it. You already know it. You already know it. Like, what derivative, what function derivative is going to result with natural log of x? Vincent already shared with you. Never mind, I don't want to give you extra credit. So integration natural log of x is not something we can come up with. So we need a new tool. The tool is called integration by parts. Okay. Integration by part is actually something that is often used. Is one of the foundation technique of integration. But those of you guys know integration by parts already learned that, Vincent. So let's just say, Vincent, do you know what integration by parts come from?
No. I don't even know how to do it. I just know the integration.
Okay. So integration by parts, it's actually come from product rules, from derivative, which is kind of crazy. So we're going to show you how that works. So here's the proof of the product rule. So let's just say if I have a d to the dx of f of x times g of x, you guys already know how to do that. And that's equal to f prime of x times g of x plus f of x times g prime of x. Would you say it's okay? Now let's copy and paste this. Copy and then paste. And let's just say, hey, what if I integrate both sides? And that becomes dx here and dx here. If I integrate both sides, that's gonna be, oh, that's gonna be, well, sorry. I'm just gonna be like this. Is that okay? I'm just integrate it. I'm gonna integrate both sides, so we're gonna have that situation happen here. So let's just say we can integrate both sides. What happens if I integrate this? If I take a derivative and integrate, what will happen? F of x times g of x, right? Is that okay? Is equal to integration of f prime of x, g of x, plus integration of f of x times g prime of x dx. Is that okay?
So you're gonna like spawn in a dx?
No, what I'm gonna do is I'm gonna move this to one side. So I'm gonna say, well, how do I take what's my subject here? I'm paying attention to f of x and g prime of x. So this is what I want to solve for. So this is solve for. So that'd be integration of f of x times g prime of x dx is equal to f of x times g of x minus integration of f prime of x g of x dx. And I'm gonna just trench slightly. F of x g prime of x dx is equal to f of x. This is those small changes here, minus g of x times f prime of x dx. And this is known as the integration by parts. I need to get a textbook here, and the textbook formula is uv minus vdu. I'm gonna show you. Grab it here. So we're gonna assume that u is equal to f of x. Is that okay? And v is equal to g of x. Here. Just don't want to write something wrong, so I'm going to. So I here is going to be, this is the integration by parts is going to be integration of u dv is equal to uv minus integration of v du. So let's just say assume f of x, u is equal to f of x, v is g of x. That's integration of u dv is equal to uv minus integration of v du. And this is integration by parts. Now I'm going to teach you the hard way. I'm going to teach you the easy way later. So the hard way is integration by parts. The easy way is called DI method. So there is integration by parts. That is the hard way. The second way is called DI method. It's also known as tablet method. Tablet method. There was a very famous movie for calculus. There was a guy that he teach in South LA a long time ago. I would say 30 years ago. He teach in the ghetto area, so they were always in the gang fight and stuff like that, selling drugs and doing everything. Basically, that movie, the main character, he's a teacher. He went there to teach in a high school, and he got all those gang students to pass the AP exam. But the true story is actually not that nice. That's based on the true story. The true story is they find out like this group of students actually cheated. But the movie, they make it look more glorious. So they say those people did not cheat. But nonetheless, it's still a big accomplishment by this teacher, because this teacher is teaching those kids that know nothing. They don't even know fraction. They got in the fight every day, and they base on that. So it's very. So it's actually talk about DI method in that movie, is tablet method. I'll maybe able to show you a movie scene afterwards, but I forgot the movie name. I don't remember what the movie name it was, so I'll look it up in a second. So integration by part is gonna be L-I-A-T-E, laity. Laity. That's what you want to set U as. Set U equal to laity. Laity is the order of operation. Is a switch function. You're gonna go first. So you can set L stand for logarithm, I stand for inverse, A stand for algebra, which is x squared, x to the third.
That's PEMDAS. Algebra's PEMDAS in there.
Well, that's just the order you want to set U as. If you have logarithm and inverse function, you want to set U equal to log function, because L's come before I. Okay? Or I before A. T stand for trig. E stand for e to the x. So log or natural log, okay, or inverse or algebra or trig. So let's start with the first one. Let's start with the x, e to the x dx. Now, with your current technique or from before, you cannot do integration x e to the x dx. Just because you can do integration e to the x, you can do integration of x, but not combination of both. Okay? And you cannot just integrate both of them and multiply together. That is not how things work. So you have to use integration by parts. So remember, it's same thing like U substitution. What do I want to U as? U equal to what? Yx.
Because it is the algebra.
Algebra before e to the x, right? So that's x. And usually I would do du. Du is what? 1 dx. Make sure dx. Is this okay? V is equal to e to the x. Or dv, sorry. dv is equal to e to the x. What is v? E to the x, right. V is equal to e to the x.
dv is e to the x dx, right?
Yes. Thank you. Len, do you see that's integration of u dv? Do you see that? Which is, that's what it's set up to be. Integration of u dv right here. All I gotta do is follow the formula, which is uv, in this case, will be x e to the x, right? Is that okay? Minus integration of e to the x dx. So it'll be x e to the x minus e to the x plus c. If you don't believe me, what are you supposed to do? Take a derivative. So let's try to take a derivative of this part. So let's just say, assume let's take a derivative of this part. That's going to be e to the x plus x e to the x minus e to the x, right? And this cancel out. That's equal to x e to the x, which is true. Is that okay? Is this okay?
Yeah.
Okay, now you're gonna do the question that we don't know to start with. Integration of natural log of x. And if you find your answer, you can take a derivative of it and find if it's true or not.
Oh, okay, I understand. Wait, is there not a
Integration of natural log of x dx. Am I streaming? Can somebody double check?
Even Durkin said it.
Wait, what did Durkin say? Durkin did it.
Oh, I am streaming.
He said it's gotta be one.
You got it? Same answer as before, right? Now you know where they come from. For sure, you got it? How many people have not got it yet? Keep on working on it. You got it? Open? Yeah.
I'm pretty sure I know it. I'm just still working. Because I just, figured it out.
All right, that's fine.
No, I think it's What's your answer?
What? Yes.
So why is it BB and not these? Why do you say like
Because you want one is you want that this part. You want that this part here, which is you want an integration of VDU.
like okay, yeah, because they both at 1 over X.
And you have a dv here, so
What is B? X times over X. So you need to use integral one.
It's the.
What?
at least you got it. No, Isabel, you got it. Okay. Huh? I don't know. Take a derivative of it. Tell me it's right. No, I don't want to look at it. Yeah, let me look at it. Yes. Oh, okay. Yeah. Let me do it. No, I see my fake eye. Remember? All right. So u is equal to what? What? Ln of x. Right. Du is equal to what? 1 over x dx, right? Is that okay? dv is what?
Yes.
1? Oh, dx, sorry. V is what? X, right? So I just borrow a formula. It's x ln of x. Is that okay? uv minus integration v du. So v is what? X. Right? du is what? What is it? 1 over x dx. Good. Okay, so that would be integration of x ln of x. That's going to be dx minus, so that'd be x ln of x minus x. And if you don't believe me, take a derivative to make sure that it's correct. Is this okay?
You say as you have minus x on your name.
Listen, bro, I wasn't wrong.
You guys, including yourself. Not ready.
What does that say?
Okay. Now remember, all this question, we're gonna go back and do the second method, which is the easy way. But right now, we're gonna teach you a harder way, just because I need you to understand why the rule is created. Come on.
We're doing an example.
X cubed natural log of x dx.
Is it okay if I change the variables I use to make it easier to tell between them?
I mean, you solve the problem. I don't give a shit. What do you do?
Okay.
I just remember it's uv minus v du. But I'm going to show you an easier way to do it too. So DI method. This is not DI method. This is integration by parts. All right. What'd you guys get?
I got x over 4 ln x minus x to the 4th over 16 plus c.
X of 4 over 16. Yeah.
C. Because you have the 4th already, you take that out, and then you still have to take out another 4 because it's x cubed.
All right. So this is the natural log. This is the a, right? So L liate is L is gonna be L over x. Du is equal to 1 over x dx. Is that okay? And dv is equal to what? X cubed dx. And v is equal to x4 over 4. So be uv, so x to the 4th
should now be back from A level.
minus integration of v du, so be x to the 4 over 4 times 1 over x dx. Is that okay? Is this okay? And that's going to be x4 over 4 ln of x minus integration of x3 over 4 dx, which is x4 over 16 minus x4 over 4 ln of x plus c. Do you guys get this or no? Ria, did you get this? Where you made mistake?
I just don't get the part where it's like integral b du. Like how do you get b? You know.
You have to integrate.
You had to integrate. You had to integrate this part. Sorry, that maybe I didn't stress that enough. If you integrate the dv, you're gonna get b, right? And if you execute dx, that's gonna be x4 over 4 plus c. But we don't need to worry about plus c right now. Melissa, you doing okay? Everybody out, Lyndon?
Yeah.
Corbin?
Yeah, I'm good.
Good? Okay. Shall I show you the easier method? No.
You're so mean.
You're welcome. I want you to do a harder problem.
Yeah, no, I don't.
Get it off of my paper.
There's a slight problem on this one. The reason why there was a slight problem on this one, you're gonna find it later, is you might have to do it again.
Yeah, you have to do it. You have to do it twice. Right?
2x cubed.
Oh. There's a 2x. Yeah, I have to wait.
But he changed the question.
Wait, hold on. So then, in order to find b, you have to do a second version of this.
So sometimes you're gonna get a question is
If that would end up happening, where you have to do a chain of them. So
yeah. In this case, it's 2 iteration of integration by parts. But later on, we're gonna show you why DI method is more superior, and it can avoid this. But that's why I want you guys to go through a struggle on this one, and I can show you the easier path to get there.
U is signed to yeah, and then B yeah. Well, the first U is then the second U. Correct. So what you have to do is you set up in order to find out B, you then B is whatever it's deviant that. So then you have to do. So now what you have to do is you have to set this to U. Yep, and then the yeah, there's 2 sets of it. You have to do it because there's a yeah, the first one that's correct. That's correct. Yeah, that's DB. Remember, yep.
Oh, I'm sorry. This one just a normal U substitution. This one just a normal U substitution. I said that wrong. So U equal to okay. So this one doesn't even require. My fault. So this question does not require this. So du equal to 6x squared dx. It's not this one. Sorry, I write it wrong. So this one just integration of sine of u and the du over 6x squared equal to dx. So it'll be du over 6x squared, x squared. Can this cancel out?
Wait. Are you kidding me?
Yeah. Sorry, this one I write it wrong because I write it. This one I write it wrong. Okay, so this one's gonna be integration sine of u, but just so you know, sometimes you still have to go back to the old technique. If the old technique works, you will stay with the old technique. You won't want it to do this. But the question I meant to write down is different. So this one's gonna be negative cosine of what? 2x cubed over, yeah, negative, that's it. So just normal U substitution. So this one, it turns out normal U substitution works because you don't have to do that. But this is the one that I meant to write down. So I meant to write down, it's very close to each other. So it'll be x squared sine of 2x. Yeah, so this is the one that you need to do integration by parts.
What do you want, Eden readers?
So U equal to what? X squared, good. And du is what? Okay, good. And then dv is what? 2x dx. What's the integration of the dv? Be careful. 1/2. Is it positive cosine or negative cosine? Cosine of 2x, right? Negative, right? So it'll be uv. So it'll be x squared times negative 1/2 cosine of 2x minus integration of what? V du, so it'll be negative 1/2 cosine of 2x. Du is what? 2x dx. Right, so that's going to be negative x squared over 2 cosine of 2x minus or plus this cancel out, so it'll be plus cosine of 2x times x dx. Do you see that I have to do it again? Do you see that I have to do it again? So what did u equal to here? X. Du is what? Dx. And dv is what? Cosine 2x. And the v is what? Sine 2x over 2, right? So it'll be negative x squared over 2 cosine of 2x plus x sine of 2x over 2. And a plus what? Wait, hold on a second. Minus v du, so it'll be sine of 2x over 2 dx. So what's integration of sine of 2x?
1/2 sine. 1/2 cosine. No, sorry. Negative 1/2 cosine.
I think the problem is derivative cosine is sine, not negative sine. So that's going to be what? Plus, right? Does that make sense? Plus? And that's going to be cosine of 2x times 2 plus c. And this is my final answer.
Wouldn't, yeah.
Okay, let's show you DI method. We're gonna go back, start with the first question. DI method is basically start with D and I, and you're gonna start with plus, minus, plus, like this. Plus, minus, plus, it's alternate signs, plus, minus, that's is okay. D is what you're gonna take a derivative of, and so in this case, what will be the derivative here? Well, that's just like a x, because u equal to x, right? What's derivative? D stand for derivative. So what is derivative of the x? It's 1, right? Is that okay?
Wait, hold on.
Okay, I'm gonna start with DI method. I'm gonna write down DI first on the top. I'm gonna write down plus, minus, plus, minus. This is how like you use u equal to x, right? Usually you had to do derivative of the x, which is 1, right? Do you see this is an x, this is a 1? Do you see that?
Yes.
Same thing, this one's e to the x, and integration of e to the x is what? E to the x. And you can integration e to the x again, which is e to the x, and this is 0, right? Now you're gonna feel like this is harder. It's not.
You just integrate.
So what I'm gonna show you this is gonna be in this arrangement. It's always this arrangement until it stops right here because it's 0. So you're gonna say it's plus x e to the x minus e to the x and plus c, and I'm done. Because you go with this order.
Okay, interesting. And you can do it up to 4 times, or it goes forever.
You can keep on doing until you got the right answer.
Okay, until you reach a 0.
Until you reach 0, but it's 3 situations you should stop. When it's equal to 0, it's the first situation. I'm gonna talk about the second situation in a second. But we can also do DI method with this one. Okay? So what is D in this case?
For ln x dx?
ln x, yes.
Oh,
And this is what? 1 over x, right? And this is a 1, and this is a x, right? Is that okay? So the first situation is first you met 0. Second situation is you're gonna be like horizontal is integratable. So horizontal is integratable. It's like right the situation here. This is integratable. Do you see that?
Mhm.
So you're just gonna do to integrate. So you're gonna write down the first thing is x ln of x minus x times 1 over x dx. Same thing as before. So it'll be x minus 1 dx. And that's x ln of x minus x plus c. So if horizontal is integratable, then I will integrate it. Because I don't want to keep on taking integration.
If it's multiplied.
Yeah, it's thing here. Or that you can do here too if you wanted to say, hey, that's just x squared. So then that will be x ln of x minus 1 over x times x squared. Same thing.
So you need to make sure after each time you go through to multiply the 2 and see if it
See, if
works.
you go with the traditional DI method, it would stop right there anyway. But the problem is you don't know when to stop.
I would have stopped.
But here it's gonna be 1 over x times x squared, so it's just x, and you're done.
Wait.
It's not I. Where'd you get I? Oh, I is the integration. I is for integration. So if you integration of 1, it's gonna be x. Integration of x is gonna be x squared.
When you say it's integratable, do you mean it becomes a whole number? Or do you mean if
So I will want that this one to be integratable. If it's in the middle part, it's integratable, then I will just integrate it. Okay, try DI method here. Try DI method here. Try DI method here. Try DI method here. So two situation you stop. When the D is going to 0. Second situation when the horizontal is integratable. Okay, when horizontal is integratable. So you're gonna do this one.
I understood it. So I can't now.
So what will be D here? D is the ln of x, right? Right? Does that make sense?
Yeah.
And this is 1 over x, right? And this is x cubed. And this is x4 over 4, right? Now, do you see this is integratable? So you will align this. So be x4 over 4 ln of x, right? Minus 1 over x times x4 over 4 dx, which is x4 over 4 ln of x minus integration of x3
Okay. Okay.
over 4. And this is going to be x4 over 4 ln of x. That's going to be minus x4 over 16 plus c. So if horizontal is integratable, then you want to integrate it.
Why couldn't you just keep going with it?
Usually I would tell people to stop there. It's integratable. It's less confusing, I feel like, because you don't know when to stop. If you keep on going, you just don't know when to stop because people don't know when to stop.
I know it's gonna keep going. So like, if you keep going, is it still gonna be something?
No. So the tabular method, if something's integratable, it's just gonna integrate that point.
Oh, is it table method?
It's table method.
Oh, I think it's tablet method.
Tablet method. It's tablet method. Yes. All right. Shh. The last part. DI. So plus minus plus, right? You're gonna feel like this is gonna be way more superior in this particular question.
Wait, can you give me 1 second so that I can write down the second?
Okay, the question is x squared. So same question. You're going from this to this. So what is D in this case? X squared. And then 2x and then 2, right? Is that okay? And the next one 0. What'd you say? Okay, what is sine of 2x? What's the integration of sine 2x? Negative cosine 2x over 2. Is that okay? What's the integration of negative cosine 2x over 2? Is that okay? What's the last one? Cosine of what? 2x over 8, right? So remember, you align like this. Because this one you stop because it reached 0. So your answer is what? X squared cosine of 2x over 2. And it's negative, right? Do you see that first term match, right? Minus 2x times negative sine of 2x over 4. See, this is a matching. Do you see that's matching? Negative times the negative is positive. And last one is plus 2 cosine of 2x over 4 over 8, sorry. And then that's going to be negative x squared cosine of 2x. This is when it reaches 0.
Yeah, because the first two ways to stop, right?
When it's integratable. The third word is tomorrow. 2x sine of 2x over 4.
I know.
You gotta check it.
Tomorrow we're gonna finish the last part.
You get like